Hello students, as we came to the last unit of your design of machine element, which is bearing. So in this bearing we'll start with the topic with the sliding contact bearing. As you all know that bearing are the machine elements which are used to support a rotating member. Example is shaft. So they transmit the load from rotating member to the stationary member known as the frame or housing. If you will take any practical example, you have seen the bearing elements in your bicycle. There's a bearing placed in the hub or in the back side of rear wheel of your bicycle, where you can see the slide bearing examples. So basically bearings are classified broadly into two categories as on the type of the contact. These are sliding contact bearing or rolling contact bearing. And the sliding contact bearing having the surface contact are coming under the lower kinetic pair. Means in the sliding contact bearing the kinematic pair is lower kinematic pair. What are the advantages of sliding contact bearing? These are the few advantages I have listed out. The design of bearings and housing are simple. The cost is very less. The design of cost is simple. They operate more silently, means the noise is very less. And what are the disadvantages? If you will look, then these are friction power loss are more. Frictional power losses will be more in the sliding contact. They required good attention to lubrication, means lubricating properties should be very high, or lubricating oil should be of very high quality. They are normally designed to carry radial and axial load. Note this point very carefully, that sliding contact bearing used to carry radial load as well as axial load only. And if you are going for the classification, then the sliding contact bearing can be classified into three categories based on the load carried, based on the type of lubrication, based on the lubrication mechanism. So according to the type of load carried, it is classified into three parts: radial bearings, thrust bearing or axial bearing, radial or thrust bearing. Radial bearing is also known as general bearing, that we will see afterwards. And according to the classification of radial bearing, this is your radial bearing. These are the bearings which carry only radial loads, means in such kind of bearings only radial load can be applied. Moving towards the next part, which is thrust bearing. So these are the bearings which carry only axial loads, and these are single coil thrust bearing or multi-collar thrust bearing. These are the collars, four collars as you can see in the picture. So this is multi-collar thrust bearing. So such kind of bearings are used to accommodate only axial loads. And the next is your radial thrust bearing, in which both radial and thrust loads can be applied. This is your axial load direction, then this is your radial load direction, and this whole bearing will be called as radial thrust bearing, which can accommodate both radial and thrust load. Now we are moving toward the second classification of bearing, which is according to the type of lubrication, which is thick film lubrication, thin film, and boundary lubrication. As name suggests, thick film lubrication is a type. You can see in the picture that there is a big gap between the two layers of the bearing, and while in the thin film lubrication it used to touch somewhere in between, and in the boundary lubrication it runs, or lubrication is screamed inside the whole part of the bearing. Now this is the definition. As you can see, the film thickness anywhere from 8 to 20 micrometer in the thick film lubrication, and typically the value of friction is 0.002 to 0.01 in the thick film lubrication. And in the thin film lubrication, the coefficient of friction is commonly between 0.004 to zero point 0.1, means friction coefficient is very higher compared to thick film lubrication. Now moving towards the boundary lubrication, then the typical coefficient of friction is roughly about 0.005 m to 0.005 to zero point 0.2. And in the boundary lubrication, the lubricant is continuously smeared over the surfaces and provide a continuously renewed observed surface film, which reduces the friction and wear. So in this kind of friction and wear will be reduced. So now coefficient of friction is this boundary lubrication you can see here, and this part is mixed or film lubrication, and this is your hydrodynamic lubrication part. And this curve is called as Strebach curve for the bearing friction. On the y side it is coefficient of friction, and on the x side we have mentioned bearing modulus. Note this thing in your mind. This will help you during solving of any numerical problem of bearing. Bearing modulus is mu into n divided by f. Now, the last part of the bearing classification is on the basis of lubrication mechanism. This can be categorized into hydrodynamic lubricating bearing, hydrostatic, elasto-hydrodynamic lubricating boundary, and solid film. We will see only two types as per your curriculum, hydrodynamic and hydrostatic. So hydrodynamic, in these bearings, hydrodynamic lubricating bearings, the load carrying surfaces are separated by stable thick film. Noted down, stable thick film of lubricant that prevent the metal to metal contact. Means there is no metal to metal contact in this hydrodynamic bearing. There is, means the film process or film pressure generated by the moving surface that the force lubricant through a wedge shaped zone. Means at a sufficiently high speed some pressure will be developed around the general sustain, so that general can sustain a load. Means it will rotate, then only it will get some property to sustain the load. While in the other category, which is hydrostatic, externally pressurized lubricant is fed up, or externally pressurized lubricant will be inserted in the bearing, which will separate the surfaces with the thick film lubricant, and these type of bearing do not require any motion of the surface to generate the lubricating film. Means lubrication film is already generated in the whole hydrostatic bearing, so that it can sustain more loads. So this is the, or if, as you can see, there is a entry for the high pressure oil supply, which will create a lubrication film inside. So this is, these are the few categories of classification which we have discussed. I am going through all those elasto-hydrodynamic lubricating bearing which is not the part of your syllabus, then gear and roll, then boundary lubricating bearing, solid film lubricating bearing. Now moving towards the general or sleeve bearings, as I will discuss how it will work. So as you can see, this is the full general bearing, this is partial, and this is fitted general bearing. These are the various types of general bearings, and how this hydrodynamic lubrication will work. Let's see. Yeah, so this is the general position in the hydrodynamic lubrication. So as you can see here, at the rest it will look like this, and soon it will start motion. It will start rotating from general to this bar, and after start it will look like this. And now at the running point, you can see this will form a wedge shaped. This will form a wedge shaped position or wedge shape of the motion in during the running of the hydrodynamic bearing. So this is all done for today's session, and we will see the next in the next lecture how we can solve out the various problems of lubricate bearings and general bearings. And if you will look after see the general bearing lubricants, so these are the viscosity, means what are the properties which are required for any general bearing. These are viscosity. Then you already studied this term in your fluid dynamics chapter. So, and viscosity is also expressed by these three terms: SUS, which is Sebold universe seconds, SSU Sebold second universal, SUV Sebold universal viscosity. You all know that kinematic viscosity is absolute viscosity divided by mass density. I'm not going in detail of that. And what is, how you can calculate the viscosity measurement? Mu and Cp means centipoise 0.22 s minus 180 by s divided by rho. With the help of this formula, you can calculate your value of viscosity, where rho is the density of oil. Now, this is a Sebold viscometer. This is an instrument used to calculate the value of viscosity of any lubricating oil or any oil. So with the help of that, you can calculate. Now there is a viscosity index. Viscosity index is what? The measure of variation of viscosity with the temperature. How, as temperature will increase, how your viscosity will vary. This is the value you can get with the help of viscosity index. There are some different values. For example, it is SAE 40 or SAE 10W. This you can calculate with the help of this value. Viscosity index is equals to L minus U divided by L by H, whereas L is viscosity of standard 0% viscosity oil at 100 °F, where H is viscosity of standard 100%, and U is viscosity of oil with unknown value. So you can calculate the value of U here. Now temperature effect on viscosity, pressure effects, and what are the different lubricating properties which you can take into consideration. That these are the few basic lubricating properties which should be there in the good lubricant. like it should give rise to low friction, means friction should be reduced. With the help of that, it should protect the system from corrosion, it should have high thermal and oxidative stability, it should have anti-foaming ability, it should be cheap and available in plenty. So I am concluding my session here. In the next lecture we will see the numerical and how we can solve those numerical problems of bearings. Thank you so much, and how we can design the bearing, that we will see in the next session. Thank you so much, and be connected with our GC Banswara YouTube channel for the more content of engineering aspects. Thank you.